What if you don't really want to write XAML in Avalonia? You don't have to, and you can do it entirely in code behind. Now, it's not something that's that practical, but it's a skill and a tool and an asset that you might need to know about in order to, I guess, learn Avalonia more, or in certain situations where you want to dynamically construct code, you can do it with this mechanism. So I'm not going to hand write this. What I'm going to do is talk you through the differences and how it maps, because here is ultimately the entire piece of code behind of exactly how you use the code behind versus XAML. So there's not much to write. What's better is to show you our example. So if we just open up the example we've been working through, and I can show you how effectively the program file, the app file, the App.xaml all merge together into a single code behind file that construct all of these together, including the main window, just not the exact content we have here. So it replaces all of that with pure code behind. So all of the applications start in obviously the STA thread, so the single threaded application thread. And this is a long-standing convention in applications. When you double click, run or execute something, it has to have an entry point. That's what this is. Comes into main, gets the arguments which can be passed in through command line, and then it runs this. So in the moment in a normal application, it just calls this method, which doesn't need to be here. We could just replace that in line with what this is doing. And then it calls start with classic desktop, which could also just be start. So there's those few conventions there. If we take a look at what this code behind file does, you can see the first thing it does is we have the single threaded application entry point here. It's not defined as that, but it doesn't strictly need to be. It's still going to get discovered as a static void main call. So we don't have this definition, but it's still going to work. And then what it's doing when it enters is it's doing AppBuilder.Configure, .usePlatform, and .start. So it's very similar to what this is doing. It comes into main, comes into here and does exactly that. It does an AppBuilder.Configure, goes through all that, and then the .start is placed outside. So structurally, there's no real difference here. The only difference you'll notice is the configure is app here, whereas in this example, it's just application. Well, if we quickly look at app, by pressing F12, that is this app, XAML, and code behind. So that's all this is, and it inherits application. So what we've done in the XAML is to make a new class that has an application base class. When it initializes, we load the XAML loader, which is the thing that will convert XAML here into the inline code, which is what we need. And then when the initialization is complete, it's going to specifically spin up and set a desktop main window. So this, what happens on startup, is really the main difference, and we have to understand that. So in this one, we spin up the application, the base class, and then we call the standard start. So we don't call start with classic desktop, we just call start. And we pass in app main, which is a function here, which ultimately then explicitly sets the app run with a window. Whereas in this mechanism, this fires when we initialize and finish. This then explicitly has a desktop because of this call, start with classic desktop. So it presets that up for us. And then we set the main window to this window. So contextually, that is different, but ultimately the flow is the same. And again, you don't really need to understand that if you don't want to. You can simply call this standard setup here, knowing that you need to do app.run with the window you want, versus doing this setup, which again, if you don't understand these, you don't need to. If you don't understand them, then you haven't used anything in the code that needs them yet, basically. So for the most part, we can think of the program as staying almost the same, just changing the start with classic desktop to just start, and the configure here to be the base application, not the app here. So if we've replaced this app, that means that this won't execute, but we're happy because we're going to replace this in a moment. However, what about this? So we have the XAML as well. Well, in this XAML at the moment, we define a styles and a FluentTheme. And you can see here, the very first line is to simply do App.Styles.Add Fluent, and that's passed in from the start call. So the app builder builds the application, which is why it's passed in there. And then when we call start, it receives it through app main, because this is an extension method. So there's a hidden value here where it's passed through the functions and it comes in as the first one. So this is going to receive the application as a parameter, and then we're doing App.Styles.Add and a FluentTheme, which is the same as this because all we're doing with App.Styles is going into the list, and then by putting things inside, we're doing the same as .add. So that's the exact same way of adding themes. So that covers that bit. And in this one, we also have application.dataTemplates with a local : ViewLocator. So we can replace that, and I can probably show you just in here. It's effectively going to be in this. So what I could do is temporarily just copy this code to show you that. And let's just replace that file. And now in here, where we've got app.styles, we can just do app.datatemplates, like so, .add. And then in here, new. And if we just look at what we had in here, we have a ViewLocator. So it's as simple as saying new ViewLocator. And that is exactly the same then as doing this. So at that point now, we've mimicked and replaced this App.xaml and this app. Code behind are completely now redundant. And that really just leaves then the main window. And once we've replaced that, we've replaced all of the application with a single program file. So in this example, you can already see the bit between it here is a simple case of constructing the window and running it. So to construct a new window, we just do var window equals new window. And we can see you're getting the idea of anything in XAML like this is almost like just doing a new instance of a class called window and then passing these values in like width, height, and so on. You can see are done here. So that covers the width and height. The class and data type aren't needed because the data type is syntax that allows this XAML to bind and understand what's in the binding in XAML, but that won't exist in code behind. So this is redundant, this is redundant. Icon and title can be set just like they can here. Width, title set there, you can set .icon like any other property. So there's no confusion here between this, they're all set. All these namespaces are just purely for XAML again, so they're not needed. And the designer, we won't have a designer because we're not seeing the designer, it's code behind. So again, all that becomes irrelevant. So that's every single thing on there covered. And then doing design.dataContext again, there is no designer in code behind, so this is irrelevant. And then it just boils down to making your actual UI. So when you place something inside the window, we've mentioned this before, the stack panel is the content. Well, in here, we set the content, and in this case, they've done a new text block, whereas we would just do a new stack panel. And then much the same, inside the stack panel, we could add elements like labels, text boxes, and all of these attributes just become properties just like this. So there really isn't much needed to understand how to map them. This is kind of, this one single file here explains the difference and the main differences between the XAML and the code behind. And then if you are stuck, the beauty of this is we've got a lot of scenarios here. So using application lifetimes. So that's where we currently, in this style, we do start with classic desktop. It covers it here. If you want to do that exact same format, you make a lifetime, you do a classic desktop, you pass in the args from the command line, the shutdown mode as the last window, and then you configure it with setup with lifetime instead of setup with classic desktop lifetime. It's exactly the same at that point. So you can even do that style of startup if you like. And then creating controls, you can see here a perfect example of C# code versus XAML. So if you're ever in doubt how to do them, such as say stack panels, you weren't sure, you new up a stack panel and do StackPanel.Children.Add, and that's the equivalent of embedding elements inside of a stack panel. So once there's an element inside of a stack panel, this is no longer a content because of the specialized layout element. This is automatically then added to the children. So this document is perfect for going through and seeing the differences. If you're not sure of how to handle events, it shows you that. Same with styles. So we really have a complete single page here to show you how to map really any XAML to code behind. But on that note, it's not something I'd recommend. There's rarely a need for code behind. It's much more work for defining the UI elements. It's not as well documented. It's harder to maintain in most fashions. So I would really stick to the UI actually being in XAML. That's kind of the whole point. That's why WPF was so good, and that's what Avalonia is based on. So it's good knowledge to have, but I wouldn't do this as default.